Chapter 6 and Chapter 9 review. Chapter 6, Probability and Simulation, the study of randomness. Here's 5 definitions to refer to throughout Chapter 6. 6.1, Formulas and Examples. 6.1 is a section that uses simulations that are based on a model that accurately reflects the phenomenon under consideration. The simulations represent imitation of chance behavior. Some examples of simulations would be flipping a coin, rolling a die, using the number generator on a calculator, or the random digit table. An example of a simulation would be to find the likelihood of an event happening, such as the likelihood of having at least 2 girls out of 3 children. To state the assumptions, you would assume that boys and girls are equally likely because they both have a 50-50 chance, and each child is independent of one another, meaning that having a girl does not affect whether the next child will be a girl or a boy. Then assign a number to each of the girls and the boys to represent the different outcomes. So boys would equal 1 and girls would equal 2. Create a simulation of at least 25 trials. Without a calculator, use Table B that's found in the pink packet. And when using a calculator, go to Math, Probability, and scroll down to number 5. And then under random, type in boys, girls, and the amount, which would be 3. So boys were labeled 1, so that's where the 1 comes in. Girls were labeled 2, so you type in 2 second, and 3 for the amount of children. Then you hit enter 25 times to get 25 different sets of numbers. And it wants at least 2 out of 3 children are girls. So every time you see a 2 appear more than once, you would highlight that number red or any color for the amount of girls that would be in the family. And it's found that 13 out of 25 times there are girls, so that would be a 0.52, so which is 52% of the time there would be at least 2 girls out of the 3 children. And if you use 100 simulations instead of 25, the data would be more accurate because the larger sample size would more accurately reflect the population of boys and girls.
6.2 Formulas and Examples. Some probability rules to remember. Probability has to be greater than or equal to 0 and less than or equal to 1. The complement rule, to find all outcomes not in that event, you would do 1 minus the probability of A. The rule for disjoint events, to find the probability of A or B, you do the probability of A plus the probability of B. The multiplication rule for independent events, to find the probability of A and B, you do the probability of A times the probability of B. One example problem is, in a deck of cards, what is the probability of choosing 2 cards and both are red without replacement? So you know that in a deck of cards there's 52 cards total, and 26 are red cards of hearts and diamonds. So the first probability of getting a red card would be 26 out of 52, and then you would multiply that by 25 out of 51. Since you took away a card, there would be 51. And since you took away 1 red card, there'd be 25 instead of 26. And you'd multiply those, and you'd get 25 over 102, which is 0.241, or 24.51% chance of getting 2 red cards without replacement. Another example problem is, what is the probability that a card is a king or an ace? We know that there's 4 kings in a deck of cards, and there's 4 aces in a deck of cards, and there's 52 cards total. So you're going to do 4 out of 52 plus 4 out of 52. And you're going to add, because it's the probability of A or B. So it's the probability of A plus the probability of B. And you would get 2/3, which is 0.1538 or 15.38% chance. Another example problem is, Joe and Jasmine are running for class president. Joe knows that 66% of the males will vote for him, and Jasmine knows that 55% of the females will support her. The senior class is made up of 60% males, and everyone must vote for one of the 2 candidates. To start off the tree diagram, we know that there's 60% males in the class, so you're going to do 0.6 leading to males, and that leaves 40% leading to females. Of the males, we know that 66% of them are going to vote for Joe. So you're going to draw a line 0.66 to Joe, and then that leaves 34% of the males to vote for Jasmine. Of the females, we know that 55% of the females will support her. So 55% is going to lead to Jasmine, and that leaves 45% to vote for Joe. Then you're going to cross multiply across the tree diagram, and then you're going to add the two totals for each, for Jasmine and for Joe. And so for Jasmine, we got 0.424, and for Joe, we got 0.576. And since Joe's total was higher, that means that he won the election. Another example problem is, suppose you know the probability this winter for getting the flu is 0.43. What is the probability of not getting the flu? So if the probability of getting the flu is 0.43, then to solve the problem, you have to use the complement rule and do 1 minus the probability of A. So you would do 1 minus the probability of getting the flu, or 0.43, and then you get 0.57, and that would be the probability of not getting the flu.
6.3 formulas and examples. First, a union. A union is a set of all possible outcomes that lead to at least one event occurring. Then there's the general addition rule for union of two events. For any two events, A and B, the probability of A plus the probability of B minus the probability of A and B equals the probability of A or B. Alright, so here's an example. There's a MHS football game on Friday night and a soccer game Saturday morning. The probability that MHS students go to the football game is 0.3. The probability that MHS students go to the soccer game is 0.15. The probability that MHS students go to both is 0.03. So in this case, the probability of F equals the probability that MHS students go to the football game. And then the probability of S is that the probability that MHS students go to the soccer game. And then the probability of F and S equals the probability that MHS students go to both games. So you can see that here represented by the Venn diagram, as you have 0.3, or the probability is 0.3 that students go to the football game, 0.15 that the students go to the soccer game, and then in this overlapping section is that the probability that they go to both, which is 0.03. Now, conditional probability. It gives the probability of one event occurring under the condition, or given that, another event has already happened. So the probability of A given B is the probability of A given that B occurs. And then, or as shown by these formulas. Then the probability of B given A is the probability that B occurs given that A occurs. Now to continue with the football and soccer example, here's a probability that students go to the soccer game given that they go to the football game as well. So here's the equation with the probability of students going to both football and soccer over the probability of just going to football. And the probability that students go to the soccer game given that they go to the football game is 0.01. Lastly, in general, to show that two events are independent, if the probability of A and B equals the probability of A times the probability of B, that means they are independent, as well as if the probability of A given that B occurs equals the probability of A, or the probability of that B occurs given that A occurs equals the probability of B, then the two events are independent.
Chapter